ancient Hindu great Aryabhata and Bhaskara too. According to modern archaeology, of the 46 ancient civilizations, we are the only surviving continuous culture of over tens and thousands of years because we were protected by the Himalayas from the second ice age, that is Dwaraka. Underwater archaeology, many forms of science, art and spirituality were developed without interruption until the foreign invasions in the last 2 millennia disrupted this continuity of culture. Self-knowledge, self-respect and self-confidence of many modern Hindus. Many of the scientific details, such as the concept of zero, algebra, astronomy, the decimal system and calculus, were copied by the Western invaders without any reference to their Hindu sources, thus distorting the history and education system the world over, including in India. In the Vedic period, mathematical activity was mostly found in Vedic texts associated with ritual activities. However, as in many other early agricultural civilizations, the study of arithmetic and geometry was also boosted by secular considerations. Thus, many early mathematical developments in India were followed by Egypt, Babylon and China. Aryabhata was one of the greatest mathematicians and astronomers during the period 476 to 550 AD. Aryabhata's birthplace is Kusumpura in Bihar. It appears that he was the Kulapati, the head of the University of Nalanda in Pataliputra, Magadha. Aryabhata's contribution to mathematics and astronomy is immense. At the age of 24, he wrote his famed book Aryabhatiya, which is one of the landmarks in the history of astronomy. Aryabhata's contributions to mathematics include the good approximation of 3.1416 for pi, a table of sign differences and root extraction method to solve the indeterminate. He devised the formula for calculating the areas of triangles and circles. Aryabhata did not use a symbol for zero. Its knowledge was in his place value system as a placeholder for the powers of 10 with null coefficients. Without the concept and symbol of zero invented by the Hindus, modern science and technology would be impossible. Even now, many people wrongly believe that the decimal system and algebra were invented in the Middle East. Aryabhata was one of the greatest mathematician astronomers of the ancient world who had enormous influence not only in India but also in Western science through the agency of the Arabs and Greeks. For computer scientists, the most significant of Aryabhata's contributions is the Kuttaka algorithm and his substitution code. Aryabhata's major work Aryabhatiya, a manual of mathematics and astronomy, was extensively referred to in Indian mathematical literature and has survived right up to the modern times. The Aryabhatiya covers arithmetic, algebra and trigonometry. The Aryabhatiya is divided into 4 parts. The first part, Geetika, provides basic definitions and important astronomical parameters. The second part, Ganita, deals with mathematics. The third part, Kalakriya, deals with the determination of the true position of the sun, the moon and the planets by means of concentric circles and epicycles. The fourth part, Gola, deals with the planetary motions on the celestial sphere and gives rules relating to various problems of spherical astronomy. India's first satellite, Aryabhatta, is named in his honor. At the Aryabhatta Research Institute of Observational Sciences, ARIOS, near Nainital, India, research in astronomy, astrophysics. Bhaskara II, also known as Bhaskara or as Bhaskaracharya, was a 12th century Indian mathematician. He was also a renowned astronomer who accurately defined many astronomical quantities, including the length of the sidereal year. A brilliant mathematician, Bhaskara II made the significant discovery of the principles of differential calculus and its application to astronomical problems and computations centuries before European mathematicians like Newton and Leibniz made similar discoveries. It is believed that Bhaskara II was the first to conceive the differential coefficient and differential calculus. From a Brahmin family, the son of a mathematician and astronomer, Bhaskara II was trained by his father Maheshwara in these subjects. Following in his father's footsteps, the young man too became a renowned mathematician and astronomer and was considered the linear successor of the noted Indian mathematician Brahmagupta as head of an astronomical observatory at Ujjain. Bhaskara II wrote his first work with full and systematic use of the decimal number system and also wrote extensively on other mathematical techniques and on his astronomical observations of planetary positions, conjunctions, eclipses, cosmography and geography. Bhaskara himself gave the details of his birth in a verse in the Arya Maitri, according to which he was born in 1114 AD near Vijayadavida, believed to be Bijjaragi of Vijaypur in modern Karnataka. Bhaskara II's major work was the treatise Siddhanta Shiromani, which was further divided into 4 parts, each of them dealing with diverse topics on arithmetic, algebra, calculus, trigonometry and astronomy. He is considered to be a pioneer in the field of calculus, as it is probable that he was the first to conceive the differential coefficient and differential calculus. He passed on his mathematical knowledge to his son Loksamudra, and years later, Loksamudra's son helped to set up a school in 1207 AD for the study of Bhaskara's writings. It is believed that Bhaskara's book Leelavati was named after his daughter, and he lived for 71 years.